A ladder rests against a vertical wall. So here we have a vertical wall. This is a horizontal level and a ladder rests on it. Let this be the ladder. Now it is pulled away from the wall through a distance x. You hold the ladder at this point and pull it away. Then it will slide down and it will take this position. All right. So let's say our ladder initially is in position AB, and when we pull it x unit, it takes the position CD. Okay, this is x unit. The distance from here to this point is x. And it's sliding down by y unit, means this distance CA over there is y unit. From A to C, this distance. Let's see, this point is O here. Now we are asked to find the ratio of x over y in terms of cos and sine, of course. This angle, the initial angle is given there, inclination is m. So this angle over here is m, and after it's slided or it slides down or it's pulled away, then its angle of inclination becomes n. That's all is what is given in the question. All right, so let's start. We can take, since the length of ladder is going to remain same, that means AB is same as CD. Let's say this is the length of the ladder, that's denoted by small d. That is the length of ladder. Now we need to find AC and we need to find BD. Of course, our BD should be BD, which is x. Our small x, which is BD, will be OD minus OB. OD minus OB. Similarly, this small y can be, which is AC, which is same as OA minus OC. And we just need to find x over y. Since AB and CD is L, so we will take a triangle AOB first, right? So we are going to say in triangle AOB. Can you find sine theta and cos theta? Of course we can. We can say OA divided by AB, which is D. OA divided by AB is equal to, OA is opposite to this angle M, so that is sine of M. Sine of M. Actually, we can put in place of AB, the value of AB, which is D. So we can say OA is equal to, this implies OA is equal to D sine M. All right, let's say this is one equation. Similarly, we can find OB also. OB over D, OB over AB, that is cos of M. So can we directly say OB is equal to D sine, that is D cos M. Because actually, if you want to show all the steps, you can say OB divided by AB is equal to cos of M. Then in place of AB, you will write D. So you'll get OB by D is equal to cos of M. So OB is equal to D cos M. Yes or no? So we are not showing all these steps. If you wish, you can, of course. So we get OB is equal to this. Can we find now in other triangle, you see, which is the other right angle triangle you can find? That is in triangle, yes, COD. The angle of inclination is n there. So you can find CO divided by CD. As you see, AB and CD both are equal to D. So CO divided by CD is opposite by hypotenuse again, that is sine of n, sine of n. In place of CD, we can write small d. So this will imply CO is equal to small d sine n, sine n. Now, n is the angle theta, all right? In the same manner, we can find OD. So we will say OD divided by CD. In place of CD, we can write small d, and we can write directly the way we wrote here. OD is equal to d cos n. Can we say that? OD divided by CD is equal to cos of n, because CD is small d. So we get the value of OD. So we get the value of OD, we get the value of OB, OC, CON, OC is the same thing, right? And OA. Can we use this? Since we have written here OC, so it's a good idea if you write OC in place of CO. OC is fine there. So this is also, let's write it OC. OC. So we get the value of OC, OA, OB, OD. Can we put it here? X over Y. And we get our answer. Yes. Therefore, you can say X over Y is equal to, in place of OD, we are going to write its value. OD is D cos N. Small d cos N. In place of OB also, we can write D cos M. D cos M divided by, in place of OA, here is OA, D sin M, D sin M minus OC, here it is, D sin N. Yes, that is equal to right hand side. If you see carefully, just taking D common, you get the right hand side of our expression, which was to be proved. So d time cos of n minus cos of m divided by d time sine of m minus sine of n. This d and d gets cancelled, so we get x over y. This implies x over y is same as cos of n minus cos of m divided by sine of m minus sine of n. Hence proved. So this is what you were asked to prove.